Combustion analysis of a sample of hydrocarbon produced 0.100 moles of carbon dioxide and 0.200 moles of water. What is the empirical formula of the compound? A, CH, B, CH2, C, CH3, or D, CH4. Subscripts in an empirical formula reflect the mole-to-mole ratio of elements present in a compound in terms of smallest possible whole numbers. Combustion analysis is typically used in determining the empirical formula of organic compounds, compounds primarily made up of carbon, hydrogen, and some other elements. In the case we have here, we are dealing with a hydrocarbon, which is made up of only carbon and hydrogen. In the combustion analysis of an organic compound, all the carbon atoms in the sample end up as part of carbon dioxide molecules, and all the hydrogen atoms in the sample end up as part of water molecules. Since we are given the amount of carbon dioxide and water molecules obtained from the sample, we have enough information to determine the mole-to-mole ratio of carbon to hydrogen in that sample. From the given information, we can calculate the moles of carbon atoms in the sample that was burned. The subscript of carbon in carbon dioxide is implied to be 1. Therefore, we know that 1 mole of carbon dioxide contains 1 mole of carbon atoms. We use this information to convert moles of carbon dioxide to moles of carbon atoms. 0.100 moles of carbon dioxide obtained from the combustion must have come from 0.100 moles of carbon atoms. Similarly, since the subscript of hydrogen in the formula for water is 2, we know that there are 2 moles of hydrogen in 1 mole of water. And we can use this information to convert moles of water to moles of hydrogen. 0.200 moles of water obtained from the combustion must have come from 0.400 moles of hydrogen atoms. Therefore, the mole-to-mole ratio of carbon to hydrogen is 1 to 4. The correct answer is then D. The empirical formula is CH4. Note, in a typical combustion analysis, the amounts of carbon dioxide and water are measured in grams, so we'll need to first convert the measured amounts from grams to moles.